Can we merge our body with artificial intelligence and transform ourselves into a new species? Have you heard of brain-machine interfaces such as those imagined by Elon Musk's Neuralink project? Are such projects realistic? Could we scan our brain neuron by neuron and replicate its function on other hardware? Can the brain-mind identity theory still be proven once we have more neurobiological data on the brain? I'm Dr. Ernest Valea, and in this episode we no longer speculate about brain transplants or teleportation, but examine the practical ways in which scientists seek to transform human nature by the use of AI, up to the point that it becomes part of us. And I'll speak again of mind upload, but this time to assess how it could be done in practical terms. But not before we start again with the sign of the cross. In the name of the Father, the Son, and the Holy Spirit. Amen. Most of what I'm going to say in this episode is part of chapter 3 of this book on artificial intelligence. In this chapter I mention an impressive physicalist project, the one started by Elon Musk as his newest company called Neuralink. Its aim is to achieve a mind-blowing target, that of merging technology with the human body. In our present state, our ability to interact with artificial intelligence is limited by the speed of our typing on a keyboard, or of speaking to a robot such as Alexa. We are also limited in our ability to receive data because it takes time to read information on a screen or to listen to Alexa. If it were possible for information to flow instantly between our brains and electronic sources of information, we could be much more effective in everything we do. The Neuralink project aims to connect our brains directly to the internet through a brain-machine interface. This will require inserting 10,000 electrodes, 20 times thinner than a hair, straight into the cortex with great precision, using a robotic device to prevent any damage to blood vessels. Each group of 1,000 electrodes is controlled by a chip, so there will be 10 such chips placed under the parietal bone of the skull. These chips would then be connected wirelessly to an external receiver, which could be worn behind the ear, and its software updated periodically. It is hoped that by recording the electromagnetic signals produced by the neurons in the cortex, the electrical activity of the brain will be mapped in unprecedented detail. Researchers at Neuralink will then be able to measure sensory perceptions, thoughts, and commands given by the brain as physical data. And in this way, they hope to achieve a clear understanding of how the brain works in physical terms. The mind would then be, in this view, just information produced by the brain. So a rapid transfer of information between the brain and artificial intelligence would be possible both ways. As you can guess, the obvious assumption behind this project is a version of the identity theory, which I mentioned in episode 2, according to which the activity of the mind can be read as electrical activity of the brain. So far, neuroscientists have lacked the tools to achieve it, but with this technology, they finally hope to prove it. The alleged confirmation, which would show that the mind is just a physical process that we are beginning to understand as a physical process, is the existence of prostheses for paraplegics and amputees. Prostheses like this work by introducing electrodes into the motor area of the brain and identifying the electrochemical signals that lead to a certain movement. The signals produced by motor neurons are identified, amplified, and transformed into commands given to the artificial limb. Patients with such disabilities must concentrate on a specific movement and repeat it mentally many times, so that the electrical signals in the motor area can be clearly identified and then used by an algorithm which commands these prostheses. You may have already seen people use an artificial hand or drink from a bottle, controlling it with their mind. Does this mean that neuroscientists have demonstrated the physical nature of the mind? Not if we understand what they can measure and use in such prosthetic devices. This is very important for our whole discussion of the materialist view on human nature. We must again be careful about the assumptions we follow before agreeing that the mind has a physical nature. To say that the mind directly controls the artificial limb involves a major conceptual leap. It would be more precise to say that the prostheses work as a result of recording the physical effect of the activity of the mind. If we do not see the difference between the activity of the mind and that of the brain, or between physical and mental phenomena, as discussed in episode 2, we follow the physicalist assumption uncritically, and we may think that we have found a proof that the mind has a purely physical nature. But the only proof we have when we are able to control an artificial limb is that mind-body interaction is possible. From a Christian perspective, the electrical signals recorded in the motor area of the cortex are the effect of the activity of the mind, not the mind itself at work. Remember my illustration from episode 3 about the relationship between me and my laptop. The brain could be seen either as the source or just as the instrument by which the mind can transmit its life. For a Christian, the error of physicalism would then be to attribute to the instrument, which is the brain, the role that belongs to the mind, and to study the brain in detail as a source of consciousness instead of as an instrument of it. If there is no immaterial mind behind the instrument we call the brain, there is no soul, no afterlife, and no meaning to our faith. That being said, we need to know that Neuralink does not stop at prostheses or implants to help people with disabilities, but is trying to reach a whole new level of human development. Its ultimate goal is to connect the brain to artificial intelligence and achieve a total transformation of human nature. Imagine how great it would be to connect our minds directly to the internet without using our hands and eyes, and to have instant knowledge on anything available on the internet. We would have all the content of the Wikipedia available instantly, just like Watson, the program that defeated the Jeopardy champion. You would just ask a question mentally and have the answer instantly in your mind. Or you may be able to download Chinese into your brain and speak it fluently. It is also hoped that people connected to Neuralink will be able to connect with each other and exchange information instantly. So far, the Neuralink project has only proved that electrodes inserted in the cortex can record electrical activity of the brains of animals and can be safely removed. But Elon Musk is very optimistic and says in his conferences that brain-AI direct connection can be seen as the next step in human evolution. The brain-machine interface developed by Neuralink would become the third layer of our brain. Primitive animals have only the limbic system, that is the reptilian brain, here pictured in yellow. Mammals developed the cortex, which has reached its peak in humans. And now we are about to add this new artificial layer to our brain that will connect us to AI and thus transform us into a new species. Instead of waiting millions of years for evolution to slowly take us to the next level, it is time to take its course into our own hands and transform ourselves into new beings. According to Elon Musk, this would be our chance to keep pace with the evolution of AI and not face extinction when strong AI arrives. But even if such projects could be achieved following a physicalist approach to human nature, there are two moral issues that should concern us. First, only those with these implants would succeed at keeping pace with the technology and become highly performing. Since only the rich would have access to it, non-modified humans would not be able to compete and would become probably their slaves. Second, since the chips could be remotely controlled, who would really control these highly enhanced humans? A central command unit would be able to shut down anyone who becomes inconvenient and reduce him or her to the level of a monkey by the new standards. So the potential for total control is lurking even in this utopian society of superhumans. Now, if you think that Elon Musk is exaggerating with his futurist project, be prepared to meet the next level of futurist philosophy on human nature. It is called transhumanism. While humanism is the pursuit of human perfection by means of reason alone, devoid of any religious influence, transhumanism aims at transcending the human condition itself and transforming us into post-humans. This would be a new species in which AI technology is fully integrated and our present biological part retains a lesser importance. A post-human being will allegedly be either a cyborg, partially human, partially machine, or something no longer biological at all, a conscious machine of a kind of next generation Sophia, or just an electronic entity in a virtual reality, like a Superman in a video game. Nick Bostrom, a key representative of transhumanist philosophy, presents it as, I quote, a way of thinking about the future that is based on the premise that the human species in its current form does not represent the end of our development, but rather a comparatively early phase. The kind of progress foreseen by transhumanists is not just about improving the quality of life by using brain-machine interfaces, but about achieving immortality. Death is seen as the ultimate imperfection to be overcome and the ultimate threat to their dreams of unlimited progress. In the words of Max More, another leading transhumanist, I quote, "Individual death makes life meaningless as it disconnects us from everything we value, whatever it is." There are two basic philosophical assumptions that lie at the foundation of the transhumanist project to defeat death. The first is that we are just physical machines of great complexity. It is the same assumption that fuels the hope that strong AI will soon be achieved. Only if we are 100% physical beings, and the brain is the hardware from which consciousness emerges, can we speculate on ways in which the mind could be uploaded to a machine. In other words, only if humans are machines themselves can we hope to survive by merging with the robot. The second assumption is that consciousness must emerge from the complex structure of our brain. So, transhumanists expect that an exact replica of the brain, achieved by scanning it in the minutest detail, neuron by neuron and synapse by synapse, would attain consciousness. Memories, feelings, and hopes would be nothing but information encoded by the connections between our neurons. This idea of duplicating the exact neural structure of the brain in order to duplicate the mind with all its memories and beliefs is called whole brain emulation. However, there are two major obstacles to be overcome for transhumanists. The first is of a technical nature, on how to scan the brain in sufficient detail, and the second is philosophical, asking whether this information would in fact preserve personal identity. Before joining in the enthusiasm for attaining immortality by means of technology, we should be aware that these two difficulties pose serious threats to the transhumanist dream. So let us examine them in the remaining part of this episode. In order to imagine concrete ways in which the mind could be copied and uploaded to a machine, we must first understand what the mind is and how it works. This is a principle valid for any function we want to reproduce by artificial means. For instance, the function of the heart has been reproduced already because scientists first understood how it works. They studied how the heart pumps blood and reproduced its function by a mechanical device that is powered by an external battery and a pump. There are hundreds of people living today with artificial hearts as a temporary solution until a heart donor is found. But when it comes to reproducing the brain, we face a completely different situation, for we are far from understanding how it works. This machine that transhumanists are trying to emulate is made of about 100 billion neurons. Each of them has up to 10,000 synaptic connections to other neurons, which means that there are about 1,000 trillion such connections in our brain. When it comes to scanning the brain in sufficient detail to emulate its processes, the technological difficulties we meet are mind-blowing. When they calculated the amount of data that would result from a detailed scan of our brain, neuron by neuron and synapse by synapse, even transhumanist enthusiasts like Bostrom and Sandberg reached shocking conclusions. I quote, "A tenth of a cubic millimeter at 400 pixels per micrometer resolution and 50 nanometers section thickness would compressed contain 73 terabytes of raw data. A full brain at this resolution would require 1 billion terabytes. Now think that your computer hard disk has probably just 1 terabyte of memory or even less. So we need the memory of at least 1 billion home computers for storing the data resulting from scanning just one human brain. Here's a helpful image. An external hard disk like this one, which we use to store our precious data, has 1 terabyte of memory, that is 1000 gigabytes. If we try to store the information from a human brain scan, we would need 1 billion such external hard drives, and they would occupy the entire White House 6 times. And this is needed for capturing just the structure of the brain, not the dynamics of synaptic connections and ongoing biochemical processes. It is not only the structure of the brain that is complicated, but also its dynamics. A neuron receives a vast number of electrochemical impulses through its thousands of synapses, each with a certain strength, and transmits a resulting signal to the neurons connected to it. The connections change over time, both in number and in strength. The signals between neurons are mediated by specific chemical substances called neurotransmitters, which are released by one neuron in the space between synapses and produce an electrochemical signal in the next neuron. The concentration and types of neurotransmitters are other important variables that determine the functioning of the brain. Roberto Manzocco, an Italian author, helps us realize that even if we could take a snapshot of the brain, we would capture a single moment in time and not its dynamic nature, which is made of a continuous flow of connections, more like a film than a photograph. Additionally, knowing about a connection is not enough. We must also know what it does, how every single neurotransmitter goes through it, and so on. We essentially need a super precise chemical map of the brain. So merely scanning the brain cannot capture this dynamism of brain activity. The strength of the electrical signal between neurons is constantly changing over milliseconds, and there is a complex and diverse set of biochemical processes going on at every moment. Therefore, the huge complexity of the brain is just one difficulty in making a copy of the brain. To reproduce its real life along its trillions of synapses is a whole different story. And if you are still not convinced that a whole brain emulation is just a science fiction scenario, consider what scientists have achieved so far in matters of brain emulation in the animal world. Don't expect that they have already reproduced the brain of a mouse or of a chimpanzee. So far they have been able to just map the nervous system of a much simpler living being, that of a tiny worm called Chernohalptitis elegans. This worm is just 1 millimeter long, has less than 1,000 cells, just 302 neurons, and roughly 10,000 synapses. Although researchers mapped its nervous system already in 1986, 35 years later we are still in no position to emulate a living, functional little worm like this. Then how could we ever achieve the transhumanist dream of a whole human brain simulation and human mind upload? Faced with these difficulties, transhumanists try another path for defeating death, that of imagining survival as a mental clone. If we could store all the details of our life, all our memories and experiences as a mind file, and then produce hardware that could run this mind file, we would get what in transhumanist terms is called a mind clone. Instead of depending on a frail physical brain, such a mind clone could run on a computer as a computer simulation and be acknowledged as our digital self. Would this be a way of defeating death? In order to understand how this idea would work, let us think of the Avatar Emilia developed by AP Soft, an impressive feat of AI in the domain of customer service. She pops up on a computer screen as automated customer service for banks, insurance companies, or IT service requests. Emilia is endowed with many capabilities needed by a transhumanist avatar. She is based on a human model working for IP Soft, the real person Lauren Hayes. Lauren was copied into an animated 3D character in a similar way in which actors have produced animation characters for movies and video games. Everything in the way she talks, moves, speaks and smiles has been digitally captured into the electronic avatar called Emilia. You will be impressed how realistic Emilia is, especially in IP Soft shows in which she interacts with Lauren, her model. The reason for such a detailed scan is not to assure Lauren's immortality, but to create a friendly interface for customer support in order to improve customer satisfaction, for it seems that our culture responds well to human-looking AI. Emilia is probably the closest equivalent of how a mind clone could exist in the future as a way of surviving death. So let us imagine the following scenario. Instead of loading the physical characteristics of Lauren and customer service software into the avatar called Emilia, let us suppose that IP Soft loaded as a mind file Lauren's real mental life, all that she has ever thought, learned and done. Would then Emilia become Lauren? Of course not, for they could stand side by side in shows and chat with each other. Now let us suppose that years go by, Lauren continues to store all her memories in this avatar, and as we all come to pass away, after many years Lauren dies. Would she survive as Emilia? Of course not, for Emilia remains the same computer simulation she always was, a simulation that mimics consciousness. Emilia keeps a lot of information about Lauren in her electronic memory, while Lauren's inner life, experienced in the first person, is gone. The same story goes for the computer avatars imagined by transhumanists. They would be instances of another kind of customer service, one meant for comforting family members after the loss of a loved one. In reality, no matter how much detailed information might go into the memory of a computer avatar, it would not be the person herself, but a simulation. In other words, transhumanism would perpetuate the illusion of personal identity for those who are ready to accept it. In conclusion, AI cannot provide a solution for the survival of death. Since human beings are not just complicated machines, technology could only fool us into believing that we could be transformed into a new species, or transferred into the body of a robot, or survive as mind clones. In the next episode, we assess transhumanist philosophy more carefully to understand its aim from a Christian perspective. Until then, please make sure you have subscribed to this channel. God bless you.